I guess first question would just be even what we were already talking about before about that gradual trend, but then there's also the peak on top of that, and then how that's impacted ocean temperatures and kelp.
So there's two ways that the ocean temperature has been changing due to climate change. One is this very gradual increase over time. But then secondly are these episodic events referred to as either marine heat waves or an El Nino event. And so it's especially those episodic marine heat waves or El Nino events that get really increased ocean temperatures that affect the kelp.
Gotcha. And then why does that affect the kelp?
Yeah, excellent question. So there's a relationship between water temperature and the nutrients in the water, such that as you increase water temperature, there's lower nutrients. And what that does is reduce the productivity of the kelp so that the kelp is not growing as fast as it usually does. And this is important because, like terrestrial trees, they're shedding leaves or blades that fall to the forest floor, just like an oak forest or a redwood forest. And the sea urchins sit on the reef and wait for that food to arrive, and they just sit there and eat that material as it hits the floor. When that productivity declines and you reduce the amount of drift or blades that are falling to the floor of the forest, they go nuts and they start eating whatever they can find, and they will completely wipe out the forest in that location, shifting the forest from the forested state to what we call an urchin barrens.
So just to make sure I understand that. So you have a kelp forest, and then in a healthy environment, they have a bunch of nutrients, they're dropping their leaves. But then when the ocean temperatures get too high, then they're stressed to the point where not as many leaves fall, so then the urchins basically eat them instead of the leaves.
Exactly. Yeah. Once you reduce the amount of kelp blades that are falling to the reef floor, then they start looking for other things to eat, and they start eating the plants themselves.
So I guess my question on that, I remember in high school environmental science, we had this like video game thing where there was a deer population and then we'd add some wolves to it.
Right.
And then the wolves would explode and then the deer would go small, but then since they had less food, the wolves would crash and then the deer would come back.
Exactly.
So why doesn't that happen in this environment where the urchins, now they don't have enough to eat, so then they crash and then the kelp comes back?
Yeah. So what's problematic with these changes is that you would expect, once you create these urchin barrens that don't have much algae for urchins to eat, that they would starve to death, right? Like most systems where you get overabundances of grazers, their populations crash, and that allows the kelp to come back. The problem is urchins don't die. They're like, literally, they're like little zombies. They will reduce their internal organs, but they'll be able to continue to absorb nutrients and continue to graze some food off the reef surface. So they simply don't die. And so those urchin barrens persist for decades.
The next question off of that was if the urchins basically sound like little cockroaches of the ocean,
Yeah.
is there any predator that will take them out?
Well, so what we had hoped here in Central California is that sea otters would do that, right? Because sea otters are the most important predator controlling urchin populations along the coast. But in the urchin barrens, where these urchins are starved, they're not worth eating. And so the otters will not eat urchins in the urchin barrens. However, they will focus their feeding in the remaining forests, and that's critically important because they're protecting those remaining forests, but they're not contributing to the recovery of the forests from the barrens.
Interesting. So otters are picky eaters.
Exactly.
And then I also heard that there's something that happened with sea stars, which would also eat urchins. Could you explain
Right.
what happened there, and then maybe if that
Yeah.
is connected to warmer ocean temperatures as well?
Yep. So the year before the 2014-16 marine heat wave that reduced the productivity of the kelp, was the sea star wasting disease. That was an epidemic for sea stars that swept from Alaska all the way to Mexico. And one of the species that declined dramatically is the giant sunflower star, which is a predator on sea urchins. The giant sunflower star in central California was never really that abundant. In the northern California region, they're very abundant, and they are the major predator on urchins up there. So when the sunflower star numbers declined, now you no longer had a predator, especially in northern California, which again contributed to the outbreak of the urchin grazing.
And was the reason that disease became so prevalent, or maybe the reason the sea stars were more susceptible to it, was that tied to worm erosion, or was that just kind of a random occurrence?
Yeah, great question. And actually, the sea star wasting event occurred in 2013, just prior to that marine heat wave. So there's been some work, especially further north up the coast, Oregon, Washington, where it is thought that temperature may have contributed to the disease outbreak. But down here, the disease outbreak occurred prior to the warming of the ocean.
Oh, interesting.
So and then what happened is you had both of those things here in Central California happening one right after another. So it's the double whammy. The predator numbers decline, the food source declines, and the urchins go nuts.
Oh, that's a drastic situation for the kelp right now. So I guess there's maybe two ways to go off of that. So kelp sounds like it's in a very bad position. And that could be both bad for biodiversity, but then also human impacts as well.
Yeah.
Could you first touch on why is kelp important to the natural ecosystem?
With respect to the natural ecosystem and not thinking about human consequences, as I mentioned, giant kelp is thought to be second only to bamboo with respect to how fast it grows. And so it's hugely productive. And all of those blades that are falling to the forest floor, they are a major source of food for the entire ecosystem. And so any decline in kelp production has a big impact on the productivity of the whole ecosystem, which has consequences for the productivity of the fisheries that are associated with the kelp forest, both recreational and commercial. And then further north in Northern California, it undermined the commercial red urchin fishery as well as the recreational red abalone fishery, because those purple urchins just outcompeted both of those.
Oh, interesting. So we're already seeing the impacts that this is having on fisheries. And
in fact, the red urchin commercial fishery in the North Coast was designated a disaster fishery, right? So that was a federal designation that is not easy to get, because that means the federal government provides financial support for the fishing industry to help compensate for the disaster. And yet it was so obvious that the impact to that red urchin fishery was disastrous.
And then on the Central Coast, are we seeing anything happen to our fisheries? Have we lost enough kelp already that the fish population's already going down and fishermen are struggling?
Right. Here in Central California, because we don't have an abalone or an urchin fishery, the effects for fisheries have been much more subtle. One of the key concerns is that the kelp provides nursery habitat for young fish, including, for example, the rockfishes that are really important recreationally and commercially. And so whether that loss of the nursery habitat for those species will eventually lead to declining catches is yet to be seen, but is a certain concern.
Nice. Then you touched on the fact that kelp is, I think you said, second in productivity to bamboo.
Yeah.
So would that also impact climate change? I'm thinking of this turning into a positive feedback loop where the ocean's warmer because of climate change. So then kelp is stressed. So then kelp is not only growing less, which takes up carbon, but then you'd also have less carbon turning into oxygen. Is that something we're seeing as well?
Yeah, the concern is like you mentioned that because of its great productivity, the kelp itself is pulling carbon out of the water, and the ocean is the biggest sink for carbon dioxide, right? It's helping to buffer the increased carbon dioxide in the atmosphere. So the thought is that kelp contributes to pulling that carbon, but then the big question is how long that kelp will keep that carbon. And so there's some thought that the kelp that gets torn off the reefs and transported into deeper waters would be a means of sequestering that carbon. But it's really unclear just how much that happens, especially when you recognize how much kelp ends up on the beach every year due to storms, right? So the fate of that carbon is not entirely clear once it's been incorporated into the kelp.
So the fate of the carbon maybe doesn't have as big of an impact on climate change. Is there at least enough kelp that we see more of an impact does it do photosynthesis?
Yes, you bet. And so actually, the increased carbon dioxide in the water should enhance the growth and productivity of the kelp. It photosynthesizes just like terrestrial plants, and so which requires CO2. So in most of these algae, seaweeds like kelp actually benefit from those increased carbon dioxide concentrations. But the problem is you have these temperature effects and the limited nutrient availability, so that the plant, it's having some positive effect, but it's being overwhelmed by the negative effect.
Final question. It sounds like it's in a pretty bad position. So is this something that maybe the ecosystem will just sort of correct itself like we see happen in nature? Or is it something where there's actually human involvement that has to take place in order for restoration to occur?
The kelp forests declined and were lost back in 2014. And those kelp forests that were lost, both on the north coast of California and here on the central coast, have yet to recover. For the longest time, we thought that they would recover naturally once the marine heat wave was over, but they haven't. And the natural recovery would be to, say, disease of those sea urchins or big storms, knocking those sea urchins off the reef, which we had hoped would happen given the big storms we've had the last couple of years. That has not happened. And so the state, the broader community, and the fisheries are all thinking about the need for restoration, for humans to come in and intervene, which would likely involve the removal of those urchins in order to facilitate the recovery of the kelp forest.
Gotcha. Get rid of the cockroaches.
Yeah.
I also lied when I said one last question, because you reminded me of another one that kept popping up in my research, but I couldn't find the answer to it. So you mentioned storm activity.
Yeah.
And one thing, might have been Allie who mentioned this, is that with climate change, there's stronger storms, so then that can actually rip the kelp out.
Right.
Is that also an impact there? And then the other question there is, we've also heard, or I was also saying that kelp can act as wave attenuation. It's like the $100 word I learned.
Yeah,
but
it doesn't actually. Yeah, most of the studies that have actually looked at the effect of kelp in attenuating wave energy as a means of preventing coastal erosion hasn't really played out. There's not strong evidence for that, unfortunately. But that's the other problem. You know, for every environmental event like storms, there's a positive side and a negative side. So the positive, like we were saying, is it may remove those urchins, but the negative side is it can remove the kelp too. Right. So if we keep getting greater intensities and frequencies of storms, that too is certainly not good for the populations of kelp.
I think that now has answered all my questions, but I'm
good.
sure there is maybe something that I missed that maybe you're thinking is important, or if you just wanted to summarize, or any last words.
Well, to me, you know, when we think about global climate change and how that's impacting our lives, these kelp forest loss and then the losses of biodiversity with that, the impacts to fisheries. Those are real manifestations of global climate change right here in Central and Northern California.
Nice. All right. Well, thank you very much. That was
Yeah,
that was a great conversation. I love
Good,
that.
good. Cool, cool.